test the series. I think we've seen it before. From k equals 1 to infinity, ln of k over k for convergence. Or divergence. So I'm pretty sure we did this example back when we did the integral test. But for a lot of these series, you can use multiple tests sometimes. So this is one where I'm going to go ahead and do the comparison test, okay? So I have my original series. Does that have positive terms in it? Yes. Okay, so maybe I can do a comparison test. So now I've got to I got to come up with a different series. So the one I'm going to come up with is going to be 1 over k. I keep the denominator the same, but I change the numerator to 1. Does that series have positive terms? 1 over k? Yeah? Okay. So now I've got to figure out, we've just said that these both have positive terms. So now I need to compare the two. ln of k over k, 1 over k. And I got to figure out which one of these is larger. The ln of k one, right? It's not larger for k equals 1, right? Because ln of 1 is 0. But after a certain point, it'll become larger, right? So this is going to be greater than 1 over k, provided that k needs to be greater than e in order for that to be true, because ln of e is 1. So in particular, k should be greater than or equal to 3, because remember k, they're integer values.
How did you get 3?
Because e is 2.7 something, and k can only be a whole number.
So you just
Round up, yeah. That's why it became equal to as well. Okay, so I've got my relationship between these two. So now I need to think about the series that I'm comparing my series to. So that was 1 over k. I want to know, does that converge or diverge? It's a p series. So yes, it's a p series. What's my p value here? 1.
It's less than or equal to 1 and diverges, right?
Yeah. P is less than or equal to 1, so it diverges. 1 is the cutting off point for a p series. Okay, so this, remember, if my b sub n, if it diverges, I need my series a sub n to be bigger, and it is, right? This smaller thing diverges, so this bigger thing has to diverge as well. So this tells me that from k equals 1 to infinity, ln of k over k diverges by the direct comparison test, okay? If you look back to what we did with the integral test, you're going to see the same exact thing. Our conclusion was that it diverged, but now we don't have to compute an integral. So it's saving us some extra work. Yes?
So you just test the simpler of the two? Or you test...
So you have one that you're starting with, right? So the one that you test is the other one that you create. Because if I could tell you if the one I'm given converged or diverged, I wouldn't have to do this comparison test. So I create a new one, and this is the one I need to test to see if it
So
converges.
the ones that we're being written are the ones that are inconclusive.
Yeah, that you don't know, do they converge or
Yes.
diverge? And so then you create something new. You should be able to tell if this new thing converges or diverges, and then you can make a conclusion. Yeah.
So like, how do you know which one's going to be A sub n and which one's going to be B sub n?
A sub n is always the one that you start with in the problem, and B sub n is always the one that you create.
Is there anything else that you could have gotten for your calculator?
Another example for this.
Yeah.
I mean, you could have taken a different multiple of 1 over k. I don't know if you could have created a entirely different series of stuff.
So how did you get to 1 over k?
Okay, so if I'm going to use the direct comparison test, whatever I create, I have to compare them. So I have to be able to say that one is larger than the other. So usually because I have to make this relationship decision, I don't change too much. So in this case, I kept the denominator the same and I only changed the numerator here. So usually I'll just make small changes, not anything too big. The one thing is, I want to also say, let me scroll back up to the actual statement of the test. The direct comparison test doesn't always work because what if the one you're comparing it to is convergent, but this inequality is not facing the right way? What if A sub n is bigger than B sub n? So it doesn't always work. And I'm going to show you something else that will always work later on.
What do you do if it's a negative term?
If it's negative, you can't use comparison test at all. You can only use it if it has positive terms. So today we're only talking about series that have positive numbers in them, no negative numbers, okay? So I kind of create these through making small changes, and the more you practice coming up with this new series, the better you'll get at it.